Okay. 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 So what is your expectation? I can imagine. So for your office, what tool do you use in terms of your analysis and all of that? Oh, okay. I see. Well, I understand where you're coming from. So, Excel, in terms of data analysis, all right, there are different tools to what you can achieve for data analysis. There is Excel. Excel is fundamental. Okay, so within Excel, you have a data analysis tool kits. Okay, which you can have it added on to your Excel software. Okay, so it's an add-on which it has to be enabled. Then you can as well run through some analysis in terms of regression, correlation, standard deviation, five number summary, your summary statistics like your uh, mean, median, mode, percentages, and all of that. Then, which also you can run through some charts and get some visuals across data sets. And one interesting thing about Excel is also the ability to write scripts, okay, to automate some of these processes that you do. And more so, you can use pivot tables to format your data. Okay, so Excel is one aspect of data analysis tool that you can use. So when it comes to Python, now let me give you guys the difference of what you do with Python. So for Python, you have an elaborate environment for which you can work with. Why? Because it's scalable. It's scalable. With Excel, you have a limit of data set you can run with Excel. So Excel data set that runs in millions of cells, runs in millions of row. You Excel will not have the optimal performance to be able to run analysis on it. Then while you can bring that to Python, Python will be able to run through millions and millions of rows that you can run analysis with. So it's because where you're going, where you're heading to, you need to have the strong foundation as you build up on it and you progress. Like with what Python will do for you will help you to accommodate different libraries and different packages to analyze your data in terms of visuals, in terms of data formatting and transformation. There's a limit to what you can do between the platforms. So, but trying to relate it with what you do is maybe you don't have the I mean, you don't have the libraries within which you should apply that you are yet to understand. Okay, to apply to financials. So for financials, the analysis can be different in terms of the level of in terms of the level of um, required analysis to be done. It may just be a thing of plus and minus, and trying to reconcile balance sheets and other things that comes with financials. Okay, so it may not be as robust as using Python to do that. So, but in terms of the reward of data analysis, we're talking about being able to go through with some data distributions and um, you know for generality's sake, you can be able to explore um, data sets in different formats, okay, on Python. You can't import a SQL from Excel, or you can't read the data that is from a SQL server in Excel, okay. You can do that with Python. You can you can as well do read data in JSON format in Python. So it's because of the robustness that Python is being used as your as the tool for this your course, okay, and that was deliberate, okay, so that even outside of the shores of this country, you can be able to thrive, being that you have knowledge in Python programming skills for data analysis. You will be taken as a hot cake. This is me telling you the truth. Taken as a hot cake. So having that skill at hand, that you have an experience doing data analysis with Python, is a plus as a data analytics professional. Okay, so you might be good at Excel, you may be good at Power BI. Okay, so Power BI is more like the visualization part of it. So, but in terms of you building up your career as a data analysis, having Python skill is I would say is not compulsory. It's not a must, but is necessary. Let me put it in that form so that I will not put you guys on a hotspot. Is necessary. Okay, so that being said, um, work with what you have and explore further and move beyond your comfort zone. Okay, learning is what keeps you going, so that at the end of the day you become a seasoned and well-rounded professional. Okay. Alright, you're welcome. All right, so let's go into the business of today. um while we are still maybe hoping that others will join us on the call. We are not, the number I see here is not encouraging enough, but we'll start, however. Okay, so we are going to go into the fifth module for today's live class, and which is about the last module. Then also we will I'm going to let you see how the project exhibition and exposition is. Okay, so when you are going through your own projects, going through your own project, doing your own project, you'll be able to know how to present your results. Okay. Um, all right. So the method and the workflow of data analysis is the same across board. It's industry agnostic. It can be applied. So what you need to understand is just how the workflow is and the steps to go through to achieve your objective in your analysis. First of all, you need to understand your business need and you proceed further with that. So I'll be sharing my screen shortly. You let me know when you can see it. Okay, my screen is up. Can anyone see my screen? Okay, so um, right, so because you're getting to the final module, which is the fifth module, and you'll be given you'll be given I mean 2 weeks duration to work on your project and get your presentation done. All right. So I think after this class you'll be enrolled for a master class in building up your presentation. Okay, so that you'll be able to present your results in the way that can be well understood. So at the end of the day, understanding how to tell your story through data is going to be very um, it's going to help you to be able to present your results appropriately. So it's one of those skills as is also required, that you can be able to tell your story through the data that you analyze. All right, so I'm going to just go through this slide and let you in into what you need to know and how to go about doing it, so that when it comes to what you are going to present as your own project, you are well guided. And don't worry, the resources will be shared to you. Some sites to which you can get data sets, okay, to explore on will be shared to you, and I indulge you to get involved and enroll in some of those things. I mean, get indulged and access those resources and explore it and use it. It's going to help you. Okay, right about now, this is assumption that I'm the one presenting my results to you. Okay, with the course, project being within the course is predicting used car prices, and by that, we want to showcase at the end of the day what we are predicting, how we are predicting it, in what way are we predicting, what are the futures are we using to predict, variable of interest that are involved that are serving as good predictor of car prices. So all of those are question banks that we want to answer. Okay, at the end of the day. So here we have this, and the agenda is business understanding, data preparation, modeling, evaluation, and deployment. Okay, after all said and done, you deploy your analysis to production. The business understanding, what does the business need? Okay, so we want to understand what the business need. The business, you need to assess the situation and get to receive the resource requirements, as well understanding the assumption if there's anyone, as to what you need to meet up for before going to um, carry out your data analytics project on it. Then you have a project plan to initiate for your initial assessment tool, so that you can as well know what tool to use in carrying out your analysis. Because when going through data analytics projects, you need to know, okay, what data set do I need, what approach do I need to acquire, what I need to acquire, and what tool do I need to apply. Is the data set less than 67,000, or is the data set less than 50,000 data sets? I mean, data points. You use Excel, okay, but with Excel, you're only restricted with what you can use within Excel. You cannot scale, okay. So, but that will determine what you want to achieve at the end of the day. All right. So, for what we have, we are looking into understanding our business, assessing the situation that is involved. So, we know that what we want to do is to predict used car price. So, let's assess the situation. Reading through, the prices of new cars in the industry is fixed by the manufacturer, okay, with some additional costs incurred by the government in the form of taxes. Customers buying a new car can be assured of the money they invest to be worthy of it, while but due to the increased price of new cars, and the incapability of customers to buy new cars due to the lack of funds, especially that's actually the major constraints of buying new cars because of lack of funds. Used car sales are on a global increase as a result of that. And by Paul Aurora, referencing and citing his work, Palakoti 2018, giving that instance about used cars being on the global increase. There is a need for a used car price prediction system to effectively determine the worthiness of the car using a variety of features. All right, so we have assessed the situation on ground. What we're able to find out, we're able to find out that new cars are expensive, and due to lack of funds, many people don't buy used cars. I mean, new cars. They go for used cars like the Tucumbos and the likes. Okay, so because of that, um, they have a need for using, I mean, going for Tokumbo cars. So now, what are the target clients that we are looking at to um, do this work for? Trying to get a prediction system to determine how to predict car prices. For used car sellers, dealers, they are the one of the biggest target group that can be interested in results of this study. Okay, so we are trying to target what we're able to find out at the end of the day for this project to those who are the target audience. Okay, in this case, used car dealers, those that sells cars. All right, so they may want to have some criteria to use as to set the price of their cars. Some may not be aware. They may just look at the body of the car. If the car is looking touche, if by the word normally used, if the car is looking slick and fine and all of that, but within the working function of that car, the car is nothing to write home about. So you don't buy car because of the looks. You buy car because of the functionality. The looks is secondary. You can always modify the look and apply body modifications to it. But having to get the functionalities of cars is very important. Is the car AC working well? Is the car engine strong enough to travel interstates? Okay, so these are the some of the things you look at. All right, so that being said, then the individuals, they are the lots of individuals who are interested in the used car market at some point in their life because they wanted to sell their car or buy a used car. In this process, is a big corner to pay too much or sell less than its market value. Okay, so depending on the context of what it is you're looking at for, the individuals are also one of those target audience that you will want to share your results to. Okay, all right. By data understanding, that is the next line of approach. Okay, so before now, I believe I've shared data analytics life cycle with you on how to go about your data analysis, and secondly, the CRIPS method, okay, the cross industrial process of data mining methodology that is used globally for data analytics projects. In terms of the guide, I want to assume that I've shared that with you, but if I have not, I'm going to do that after the class. Okay, so with that being said, you there is always an approach to follow in carrying out your data analytics projects. The CRIPS data mining methodology is widely used and adopted in carrying out data analytics projects. Even when you check ChatGPT, okay, because right now the rave about ChatGPT here, ChatGPT that is very, yeah, AI is evolving and it's evolving and trying to look out to make our work easier. It's also a very good thing, and at the same time, how to be able to use this inventions that come out is very very important. Okay, so because right now it's still under development, what we need to understand is that data analytics projects, this workflow is similar and it's same across all board. Industry agnostic, it can be applied to various industry and it can be used anywhere, so long you have a data. Okay, so long you have a data, it's all about the data. The data is what will determine. So here, the data understanding has to be, you know, taken into consideration as a first. After understanding the business need and this objective, next is to understand the data that can be used to answer the business question. Okay, so collecting the initial data would be that collecting data collection. I mean, the initial data collection reports. It can be in form of survey. It can be in form of questionnaires. It can be in form of polls. Okay, so that's like a primary source of data collection. Then you can use data sites. There's Google Finance for financial data. There is Yahoo Finance for financial data also. There is data.gov for governmental data. So all of those are, are resources to data sets that you can explore and use, okay, for other purposes. So yeah, subsequently that will also be shared for you guys. Then you can describe your data, understand what your data is about, exploring your data, and verifying the data quality. So for the case of our project in this course, which is about predicting used car prices, you see that our point here is that we want to understand our data from our data sets. Okay, from our UCI machine learning repository, we were given this data characteristics as it is a multivariate data set, and the number of instances is about 205. That is the total entries of the data in it, 205. Then attribute characteristics, you have categorical, there is integer, and there's real numbers. So for categorical, you know that categorical data are those data that you have as medium, high, and low. They can be in different form of category. And then you have for integer are whole numbers. Okay, the real numbers are floats or can be called decimal numbers, depending on your use case. Then the associated tax is what is regression, what we did on it. What we want to do is okay, understanding what our data is about. So the number of attributes is 26. The data used in this project was downloaded from UCI Machine Learning Repository, which sources is given from the following sources below. Okay, so also, we are proceeding to getting our data information. So this data set consists of three types of entities: specification of an auto in terms of various characteristics, its assigned insurance risk rating, and the normalized losses in use as compared to other cars. Okay, so the second rating depends on it as well. So here, more so, we have the third factor, which is relative to average loss payments per insured vehicle year. This value is normalized for all autos within a particular size classification. Either is two-door cars, station wagons, sports, specialty sport cars, which are specialty cars. You know, depending on what it is, it could be Formula One and all of that. So, but then is we understanding the context of what our data is telling us, representing them in its form and format. Okay, so the data set acquisition and basic insight. What we're able to do is we read the data using the pandas library and structuring our data into a frame by assigning the headers to it as well. Okay, by also getting the statistical summary of our data set. From creating our data frame, we're able to describe our data header and introducing it to also make our data more readable. Okay, so for each of the columns, you have a column name, a header that identify what the column is about. Okay, so it can read your data into, I mean, giving your data to be read into a data frame, so it's well understandable for anyone that comes to want to access your data. The data acquisition and basic insight also still on it. You can see what we did. We applied some replacement of some missing values, which we discovered as with question mark symbol from the data set, showcasing the missing values and having to replace it with not a number. Okay, so as to deal with that. Subsequently, we discovered there are missing values observed in some of the some of the columns. From this entry, we saw that normalized losses has missing values. When we check the left screenshot, you see it's 164, which is about the number of normalized losses. So out of 201 entries that it's supposed to have, It has 164. So there are about 37 missing values out of it. All right. So here we discovered also that number of dots has missing value, ball has missing value, stroke has missing value, horsepower has missing value, peak RPM has missing value. You see, so using we are trying to get to know our data better, to understand where there are missing values, to also note where what data types it is and the source from which our data type was derived from. All right, so um, that gives us the idea about exploring our data sets. So secondly, we are preparing our data, and what we need to do here is to get our data prepared for analysis. So this is the second stage where we apply some data cleaning and data modification and formatting. All right, so that we can be able to explore on the need for variable of interest that we want to use as a good predictor of price, which is the target variable. Okay, so the sub agenda is the clean data, construct your data, integrate your data when we can merge data if there is need, and the formatting of our data to reformat our data to transform our data where we need to transform them, and as well to standardize it also. In terms of data preparation, based on the summary of assessments, each column has 205 rows of data and 7 of the columns containing missing data. So I am reporting, okay? Excuse me. I am reporting from the standpoint of me presenting my data, all right? And by that, what I'm doing is to ensure that I'm able to give a, an information about my data sets, what I discovered, and what I did subsequently to arrive at my outcome. Okay, on your own end, you're going to do this. You're going to be you're going to also give information about your data sets, the source which it was pulled out from, what you saw in the data set, what modification did you do to make the data suitable for the analysis that you want to do. So remember the first instance. You have to get to understand the business need. All right. That is very important. You have to get to understand the business need. And you also look out for the objective of your analysis. The objective is the questions that that you want your analysis to answer. Okay. Based on that, you'll be able to find the appropriate algorithm to be able to use while you analyze. All right. So it depends on what it is that you're doing. Now, with what I have predicting car prices on my data preparation, I have been able to fine tune the number of losses the number of missing values that I saw within my data sets. Okay, so for normalized losses, there are 41 missing data. For number of those, there are two missing data. For ball, there are four missing data. For stroke, there are four missing data. Horsepower, two missing data. Peak RPM, two missing data. And price, four missing data. So you're presenting to the stakeholders about your analysis on some things. So within your business environment or within your workplace, okay, within the organization you work, they can be like a pool, or they can be like a request, maybe like a review that can be done quarterly based on the performance of the products and services, how customers are taking in, how customers are faring with the products and services you render to them or you give to them. Okay, so you want to see how to optimize operations. So you may want to run a feedback or a customer satisfaction survey to customers that buy your products. You can be sending them out those polls to participate in, so that you get their responses and you know if the customers are happy with your product and services. You'll be able to see that from the get-go. You will know based on their satisfaction rates, okay, when you run your survey. So you are able to pull those data through survey approach. All right, so that will help you to guide your decision making process as you go forth. So how do we now deal with our missing values when we discover them? we apply some level of modification to it, which can be you can replace by mean, you can replace by frequency, you can drop the whole row. Okay, so let me explain a bit of this. I think we've already done this from our module 2, but for refreshments, I mean, so to say, for refreshers, okay, just to refresh our minds, um, the approach to what we did was to replace some of the missing values with their mean. Okay, replacing by mean, you know, mean is an average. Okay, so when you are looking at an average of something, you are trying to generalize that particular thing. Okay, let me use a real life example. For instance, um, let's say, for instance, in the context of the project we're doing in terms of used cars, on an average, the number of cars you see, the average number of, I mean, the cars that you mostly see on an average when you go out, I can bet you can bet with me that it's Toyota cars that you see a lot in the open space at any point. At least out of 10 cars, four is Toyota or four are Toyota cars. Okay, so that you're taking an average. You see what I mean? You're taking an average. So you are assuming that out of 10 cars that will pass by on the road, four of it is or are Toyota cars, or even more than four. It could be six even. Okay, because of its popularity, of its durability, and of its affordability of Toyota cars. Okay, so that is what replacing by mean is. So just in case you are having to check the data set you have and you discover there are some missing values, on what grounds can you work on those missing values to make the data suitable to give you the desired outcome on the objective of your analysis. Okay, so that is what we did on this end. So here, replacing by mean, we replace the 41 missing data by mean of the data set on an average so as to cover up for the lost grounds, the data points that are missing. And then secondly, we replace by frequency. Replacing by frequency is done by replacing mode. I mean, what frequency is the occurrence of the occurrence of the particular column in terms of its data set. I mean, in terms of its data points. Okay, the frequency of the occurrence of the data points within that column is what you use to replace by frequency. How do I mean? Let's take for instance on the number of doors. Okay, on the number of doors is a column data point that is of the data type object, is not in numerical form, so you can't replace by mean, right? So we're able to replace by mean to those numerical columns, of our data set. So for the ones that are not numerical, like the number of doors, we can replace by frequency. Then for dropping off the whole row, price is the predictor variable. We needed to drop it off because, I mean, we needed to drop off the missing values in price. Price has about four missing values which were discovered. So, but however, we can not, as a caveat or as a constraint, where your target variable has missing values, what you are left to do is to drop off the rows where the missing values are. That is about target variables. Okay, if price was not a target variable and it has missing values, we can either replace by mean or we replace by frequency. But since that price is a predictor variable, we needed to drop off the rows that has the missing values, which are about four of it. Okay, so you may want to pose a question that, okay, why dropping it off? What if the missing values for price is way above four, for instance? In that case, the data set will have to be reviewed. Okay, it may be that price can't really serve as the predictor variable for that particular data set due to the constraints in terms of its missing values. All right, so that will have to be considered and put into perspective. Moving on, we need to also analyze the individual feature patterns using visualization. So I'm explaining what I'm demonstrating, okay, in terms of project exposition as you will also embark on it, okay. Let's you also have that environment where you can display your project and explain yourself, this, I mean, interpreting your results and telling story through your data so that your audience and your stakeholders can understand what you did, what objective you're able to achieve. Okay. So at the end of the day, informed decisions can be taken based on your presentation. All right. So here on this end, we're trying to analyze individual features patterns using visualization tool. Okay. So we're able to see that engine size is one of the good predictor of price based on the visuals. And as you can see, as with the even distribution of data points around the diagonal, okay, which is line of best fit, we see that the lines are, I mean, the points are closely intertwined intertwined with each other. They're closely evenly distributed to each other, so which means that there is no outliers, which means with as the engine size increases, so is the price. So it's a direct relationship that exists between engine size and price. So out of what we discovered, engine size is one of it. Then for highway mass per gallon is negatively correlated. Why? Because the more and more, in terms of interpreting this now into a layman's term, we may not understand data crunchy words, okay, vocabs or data terminologies. Okay, so you may just let the stakeholder know that, all right, what we have here is that highway miles per gallon, being that nobody will want to run a car that consumes fuel a lot. Okay, that will be like a liability instead of an asset. Okay, so it will cost you more money in the maintenance of that car rather than enjoying the benefit of buying the car. Okay, so nobody will want to go for a car that is that is high in consumption of fuel. Okay, so as more and more you discover in terms of selling a car, and if you want to buy a car, if the if you're buying a car and you are told that the car consumes fuel, you may not want to go for the price that is being stipulated for. Okay, so you are going for buying a car to discover, okay, if this car is less consumption of fuel, if it's less consuming fuel, you are basing your criterion on the price, being that this car is going to serve me for good, and it's based on its economic value. And I will just have that mindset to say, okay, the less the car consumes for the more the price goes up. That is what this highway miles per gallon visuals is indicating. Okay, the less the car consumes for, the more the price of the car. Okay, so but there are some engine capacity that are more robust that will have to really need fuel to run, that will also consume a bit more fuel. Okay, so that is dependent. As you can see, the engine size is giving us that the direct relationship. As engine size increases in terms of horsepower or in terms of the capacity, the price of the car will also increase. You know, corroborating it with the fuel consumption also. All right. Then other features as well. Peak RPM is not a very good predictor because of the outliers and because of the data points that are far apart from each other. And so it's not going to be a good predictor of price. So we can just let go of peak RPM. It doesn't seem like a good predictor of price based on the interpretation. Okay. So then for the price on the body style, the body style is where you have the different body style of car, and it's also like a kind of good predictor of price. Why? Because the points, you're able to determine what car make serves you better. What car make is varies by price. Okay, so if sedan cars are more suitable for you in terms of price, you're going for that. If comfortable is suitable for you, you're going for convertible. Excuse me. So, hope you can hear me, please. Okay, great. So, other features also assessed. Engine location. Engine location also is a good is a good predictor of price, as with the variability of the the category between front and rear engine location. Okay, so that is giving us that is giving us that outcome as to also basing our decision making on the engine location in terms of. So now we are seeing futures and futures that are serving as a good predictor of price for us, so that when we go out there, we are making an informed decision. So this is to let you know how you can depict this on your own end in a real life sense. Okay, so that when you get on your own projects, you can as well defend yourself well enough to be understood by your stakeholders or your audience. So for the drive wheels, we have the rear wheel drive, the forward wheel drive, and the four wheel drive. Here are the distribution price between the different drive wheels categories differing, which differs. Okay, as such, drive wheels could also be potentially be a good predictor of price. But here, when you check the box plot shows that there is a bit of similarity in terms of range of price between the three different drive wheels. Okay, so when you look at the body of the box plots, okay, when you check forward wheel drive and four wheel drive, you see they're closely together. All right, so it doesn't speak. There's no distinct. The variables are not too distant from each other, so it may not really serve as a very good predictor of price as to that effect. Why? As to that effect of it not being distinct from each other enough. All right. So the next is the modeling. For modeling, we're able to see some of the modeling techniques, from our model 4. Model 4 talks about we developing our models. We use simple linear regression, the multiple linear regression, and the polynomial linear regression. So we also applied some in-sample model evaluation techniques like the R squared coefficient of determination. R squared coefficient of determination determines the percentage of the coefficients in terms of variability of what is being explained. Okay, for simple linear regression wasn't as good as multiple linear regression. Out of the three models, multiple linear regression starts as the best in terms of its accuracy and in terms of less of errors that was discovered. Okay, so I'm now explaining to you what modeling was done, and what decision was made in terms of selecting the best model. Okay, so you can see building the model and assessing it. A model evaluation using the visualization. So using the visualization also, what we did at the end of it all was to apply prediction in terms of the price the to see if there's any closeness with the observed value, the actual value itself, and the predicted value. Okay. When you talk about the actual value is the value that comes with the data sets. The predicted value are the value that is you get to impute and substitute to get your prediction out for. So remember that we had a residual plot that we are plotted in module 4, which was used as our residual plot in that sense. So the model evaluation is also giving us similar results as compared to the data preparation. Okay, so in module 3, that was where we talked about the variable of interest, where we talked about what features are good predictors of price based on our findings. So here we have a similar result as to that. So decision making process determine what a good fit is. Out of the three models, simple linear regression, multiple linear regression, polynomial regression, comparing the three models in the model development, it was MLR, which is the multiple linear regression model that is the best model to be able to predict price from our data sets. Okay, so that is what we were able to discuss. But however, you can improve on this. You can as well make your own presentation more visual, okay, than words. All right. So while you are describing and explaining, you're able to also give pointers to what needs to be understood while you're explaining. Here we have evaluation. Okay, evaluation is about the fifth model, where we evaluate our results and determine its accuracy. All right. So by that, for the three models, three main metrics for modeled evaluation in regression: R square, adjusted R squared, mean square error, and mean absolute error. They are all used to determine what we needed to determine. Okay, so what we discovered also was the model with the highest R squared score and model with the lowest mean squared error will serve as the best model. And so that was why multiple linear regression was chosen as the best model to use for prediction. Then conclusion. So our findings are the outcome of the analysis. We discovered that the selling price of used cars was fairly in the same range as of now in the future, which engine size, engine location, and drive wheels were all assessed, and having to see that engine size and engine location serves as a very good predictor of price, whereas drive wheels to some extent but not entirely a very good predictor of price. Then then the power of car horsepower, the highway miles per gallon, and the fuel type, either gas or diesel. They're also important factors that influence the selling of a car in the used car prices. So, but however, the major ones are the engine size and engine capacity, which engine location and horsepower being horsepower for your highway miles per gallon as well. Okay, so the top car amongst the cars in the data set is Toyota. Okay, so that is what we have as our project exposition presentation. Okay, so this resource will be shared to you guys. You can reference it and read through it. And if there's any question on what you're not clear about, you can ask. While I also try to give you the best experience you will get. Okay, so that is about the project exposition. Any question before we wrap up with the module 5? Okay, the floor is open for questions. Let me hear from you. Do you understand the exposition? Is there any part of it you're not clear about? Okay, Joyce, please go ahead. Hello, Joyce, your hand is up. Okay, go ahead. Okay, it's afternoon now. Good afternoon. Okay. Oh, oh, did you try reaching out to Velvet? Okay, so okay. Okay, so let me come in this way. I think the technicality of it is that the site may be down at some point. Why? Because of enrolling other subscribers and other badges. We have periodic badges. Um, as we go forth, as you are rounding up your badges, and other badges are coming in. So it may just be based on site maintenance that could have resulted to that. But however, so some other aspect may also be based on network. Okay, so but well, that jurisdiction is not my own doing. It's not where I have my responsibility placed upon. So I may not really give you all the details that you require. Okay, so that is why I asked if you reached out to Velvet on that on your request. Yes, I think that is it. Yeah. Oh, 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 okay. Well, I will apologize on the behalf. So the only thing is that, well, are you able to access now? Is it still the same experience? Do you have his number? Do you have Velvet's number? Okay, so the WhatsApp group is actually by you students. Maybe your fellow students creating a WhatsApp group. So actually, we as the instructors and the moderators, we don't have a WhatsApp group. Um, so what I'll just do right now is to share his number with you so that you can so that we can reach out to him by calling him or sending him a chat. Then let him know your queries. Yeah, I will chat it to you guys on the Slack. I mean, on the comment section of this call, so that everybody gets to see it. If any other person has similar complaints to make. Okay, so while I'm doing that, the floor is open for other persons to talk. Yes, I'm with you. Can you hear me? Yes, I'm going to write it out on the chat column. You see it on the chat column of this call. Okay, someone has just sent it. Kolawale. Yeah. So did you see the chat? I mean, the chat dropped by Ola. Not you're on this call, right? Can you see the chat column, the message center? Oh, you can't read the message, the chat that was dropped. You're welcome. So you can reach out to him. So every other person, please access the number and reach out to him if you have the same query. Okay. You're welcome. You're welcome. So, is there any other comment, observation by any other person before we move to module 5? So I'm just going to run through module 5 for us. and then we can go back and do some practice on it. All right. Then while you prepare here for your project. So I have streamlined some materials that I'll be sending out to you guys as to your completion of your program to help you for your data set that you may use, the data set that you may want to use to explore on the data analytics project. Okay, so sharing the sites with you that you also explore. So I think to start off now, you guys are familiar with cargo.com. Okay, it's one of the data source sites that you can pick data from. All right, and they come in different forms as to the objective of what you want to do. So, but however, be expecting subsequent materials as I'll be sending them forth, um, as I'll be sending them, considerably from time to time. So, if there are no questions, let's go into the module 5. The material for the presentation will be shared across both to you guys. You can as well reach out to me to let me know if there's anything you need to understand, then I will explain better on it. Okay. So presenting your data is very important. How you present it is also very important. While you try to assess the results I'm going to share on this one that I've just demonstrated to you guys, you read through, you see the approach that was used in that, then you can be able to structure yours in the same format. All right. So if there are no questions, let's proceed then. So module 5 is about the model evaluation. We already have developed a model in module 4. So what we are doing right about now is to evaluate a model. And how do we evaluate? We're only evaluating a model to determine the accuracy of the model. Okay. What do we what do we see? Is the model accurate in its prediction enough to use um for future prediction in terms of when we put it into production. Once we're done, we put our analytic procedures into production to agree and to know that okay, at the end of the day, whatever incoming data that we want to use will actually yield the predicted outcome in the right order. So hence why we are on module 5 for helping us to evaluate our model, its accuracy. Okay, so the content here is overfitting after the model evaluation, underfitting and model selection, ridge regression, and grid search. Okay, so understanding the dynamics of this will help you to get clarity. So when you go to scikit-learn, okay, remember that scikit-learn is also your resource, your go-to resource, as with what you, in terms of module 4 and module 5, the intensity of module 4 and 5 helps can be gotten from scikit-learn because most of what was used comes from scikit-learn. So here we have the different methods. We have classification, regression, clustering, dimension reduction, and this model selection. All right. So you can see from module 5, from module 5, the the fitting and model selection. You can search through some other resource on the scikit-learn. Okay, so you see the approach and the way it was used. So you can search for other as whatever it is that you want to search out for on the search box here and click go. Okay, so I'm searching out for overfitting. Let me see the resources that are available for overfitting within the scikit-learn library. Okay, so here we have them. So there is assemble methods, Naves Bay, and precision recall. Okay, so precision recall is for classification projects. Okay, then for prediction projects we have R squared and mean squared error. Okay, so that is how you determine the accuracy of your model for the different methods that you use. Okay, so there are many of them. You can get to explore them as you may want to use them subsequently. All right, so you have the documentation for it in scikit-learn. That is what it asks you for. And then other ones, ridge regression, you can also get it within scikit-learn. When you type in into the search box, ridge regression, that will also give you similar results on ridge regressions. Okay, so you get to find out what it is you need from the documentation. Then you're able to find what response that you may need. All right, let's move on. And now on this end, we don't need to install these variables. We don't need to install these packages, the libraries, as they are already pre-installed within within Anaconda Navigator. Okay, so the Jupyter Lab was pulled out from Anaconda Navigator, as you can read from the comment section here. If you are running on your lab browser, you can install these libraries using pplets. So now here is the difference. Here is what I mean. Jupyter Lab from the browser. This is from the Jupyter.org official website. Okay, so it's the same environment with the Jupyter Lab from your Anaconda platform. The only difference is that the Jupyter Lab from your Anaconda platform, I mean from the official website of jupyterlab.org or jupyter.org, the dependencies are the pre-installed libraries and packages that are already available in the Jupyter Lab from Anaconda. So you for this for the Jupyter Lab on browser, you need to install those packages as highlighted here. Okay. So but right about now on this lab, we don't need to install it because they're already pre-installed. Okay, so we're going to run through with this cell and import the necessary libraries that we need to import, pandas and numpy. So it's the same approach, all right? So what you're just going to do is what we are scanning through in mode 5 is to evaluate our model across board in terms of what we need to do. All right, so we're already familiar. So on how to import our data, but however, this is the same process we're going to go through on. So we're going to skip this cell as it is not is served for the Jupyter Lab on the browser. So we are not on that. So we're going to skip it and we run our data set again and also get to find out the numeric data, all right, within our data sets for plotting. And on this end, we see that our symboling, our normalized losses, all of the data sets, the missing values have all been treated. Okay, and some of the category and the dummy variables that were used are also in the data sets that we are using. Okay, so it's a progression. You don't have to import a fresh new data set all over again and apply cleaning and formatting your data. Okay, so here we have the diesel, we have the gas and all of that. So they're all being converted. All right, proceeding further, we are defining a function. We're defining a function on here. So the IP, the I is a Python which gets where you get to interact, import, interact some other features within the Python, and which get as it is, it's where you have some of the captions on your visuals and some inbuilt libraries that is required for the functionality that is required for your use within the module 5. Okay, here we are defining a function. If you may have received the resource on Python construct for beginners that I shared, you will know that this is one of the constructs as defined in that resource. Okay, so you are defining a function, and this function is your distribution function to apply this essence in it. I mean, to apply all of this functionality to it. So we have these different arguments: red function, blue function, red name, blue name, and title. Okay, so what this means is that what we're trying to do is we're trying to get a distribution plot, and by the red function and the blue function is giving us the differentiation of what we need to use as identifying the the distribution. All right. When what I mean by that is, okay, in terms of your predator variable and the actual variable, how do you differentiate on the distribution plots? So that's why we have red function, blue function, the red name, blue name, okay, and the title of the plots. Okay, so the title will always serve as the headers. Now, coming down also, we have another plot that we plot, polyplots. For the polyplots, we are also getting to define a function to be as polyplots, where we have our x train, s text, y train, y text, linear regression, polynomial transform. Okay, so some of all of this, what you need to know is that when you are predicting and you've done your prediction and you've done your model evaluation, you've discovered the model that best fits your prediction in your analysis. In this case, regression, multiple linear regression. Well, what you're doing is to also give room for testing your method, for testing the particular method that you're using for distribution, okay, for predicting your variables. All right, so for the S train, Y train, these are training data. Then the S text and Y test, they are testing data. So we'll come to see where we split them and use it for our analysis. So what do I mean by training and test data? For training data, it is the data within your data sets. All right. And then the testing data is the data you are going to use to test the validity of the model that was used in training your data. Okay, so let's see the outcome by understanding that. That is what we want to know in the end of it all. So here we'll go on with part one section of the lab where we are training and testing our data. Okay, here we already know our target variable to be price. Okay, so and ensuring that price data has no missing value. We've dropped off the missing values in price. Then looking at scikit-learn, remember model selection. Model selection, like I did say, okay, we are only trying to see at the end of it all what was the outcome of applying this test data in multiple linear regression. What was the outcome? And now we have our S train and white and X test. So S test training data set, S train training data. I mean S test testing data set and Y train training data sets. Okay, so we are applying the train test splits here by 10%. So what this means is that we are differentiating our data sets from training data. So our test data is going to be 10% of our entire data set, which now means that our training data is going to be 90% of the data set to be trained. All right. So in that regard, we have our test size to be at 0.10. Then the random state is equal to 1. Random state being equal to 1 is giving us uh, the level of flow that the selection is going to take. So it's going to go by one fold. Okay, that's by random state. Then we print the number of test samples, we print the number of training samples, being that we've been given the test size as 0.10. Okay, so when we run the cell, get the output on that. The number of test samples 21, number of training samples 180. So when you add these two together, you get 201. Remember, our total number of entries is 201. Okay, 201 of our entries. So now we've differentiated, we've splitted our data to help us in our training and text. Then for question one, I have our question one as this, where we are told to apply the same thing that we've done here. Okay, so what we are doing is just to replicate what has been done so far. And now in this case, what we're trying to do here is that we're trying to split our data in 40%. Okay, splitting our data in 40%. So that's what we have here. And that's going to tell us that our test data is going to carry about 40% of the entire data set. So in this case, it's 81. Okay, when you run the cell, in this case, it's 81 test samples, and the training data is 120. So remember, I did mention about the content, the objective of Module 5 lab. You are trying to also check underfitting and overfitting. When How do you identify underfitting and overfitting when your data is? You identify overfitting and underfitting. For overfitting, you that is when the training test, I mean the training data is more than the test data in terms of variability. When it is over, when it is more in the, let me explain it this way. Okay, for underfitting is when the training data is less than available. Overfitting is when the training data is more than available required. Okay, so in identifying that is that we proceed further to ensure that we're able to import our libraries that will help us in our linear model, which is the linear regression. Okay, remember we used our multiple linear regression, and we serve that as the predicted variable, the variable that was going to be used. We will use the multiple linear regression to serve as our model that will be used for prediction. Okay, so and also we're able to determine the the scores of the R squared on our module 4, which gives about the coefficient of determination on the variability of simple linear regression, multiple linear regression, and the polynomial linear regression. Okay, so here what we are doing is to see how we can be able to evaluate our model for validity and for accuracy. Okay, so and that is why we are doing test and train, test and train to just check for fitting and underfitting. Okay, so by that we have a question two, which is asking us to find the R squared on the test data using 40% of the data set for testing. So you're having a subset of analysis to do here. You're told to just get 40% of it, and by the test size is going to be about zero point 0.4 to showcase that. And then we're able to see that when we run this cell, in terms of our fits and in terms of our score, we get an output of 0.71. We get an output of 0.71, and so this output is for the coefficient of determination, the R squared, which is this score here. Okay, so this fits has already fitted horsepower train on Y train. Okay, so what we are doing, we are training our data on horsepower. Okay, but we've divided our data set into 40% to be trained. I mean, into 40%, 60% to be trained. Okay, 60% of data will be trained to give the desired, I mean, to give the output of the prediction. Then we use that remaining 40% to test the accuracy of that prediction using the model that has been developed in our module 4, which is the multiple linear regression. Okay, so on the cross validation score, cross validation is to get to validate the when you let me bring it in the context of Excel, where you know how to go through with pivot table where you can be able to cross, cross. arrange your data sets. Okay, when you cross arrange, do you still get the same outcome? Does the model still serves the same purpose when you do that? So that is what we are doing with cross validation. So we are doing that here to also see some validation that we need to get. Now we have imported the library. We have imported the library on the model selection using from scikit-learn basically, and moving on with it is that we are also applying our linear regression and our X data on the horsepower. Then the Y data is the data set of the predicted variables, which is for the price. Okay. The cross validation variable, which is equal to 4, is going to give the cross validation into four folds. All right. Then when we run this cell and determine the R cross, that is the cross validation, we have the array of four different values that are required for our cross validation check. Okay, so we can now calculate the average and standard deviation of our estimates to determine the mean of the faults. But however, let's not get too um, overwhelmed by what we're doing here. So what we need to understand is at the end of the day, if the R squared and the mean squared error is on the right side, your data will as well give a good accurate score in the end. Okay, so module 5 is an extra of what module 4 has done so far. Okay, so what we're also trying to see is to push further to get clarity on the accuracy of our model that we've selected. Okay, so moving on as to checking the overfitting and underfitting and model selection. So what we are also going to do here is to check what data is what we can see as the underfitting and what we can see as overfitting. But however, like I said, we are going to run through this lab 5 to evaluate the model. Okay, so it's an extension of what module 4 was done after being able to determine what model serves best for the prediction and analysis. At the discovery of it is multiple linear regression. Okay, so here on the second part of the module 5, we have the underfitting, overfitting, and model selection. On this end, what we are trying to do is to also get the multiple linear regression uh, variables, I mean the columns, the attributes. Okay, so as with what we've done so far, we know that we used these four columns, which are the major variable of interest. Okay, so they are the good predictor of price as being used in module 4. If you can remember, please go back and refresh your minds on it. So this is what we use. And then we are trying to see how to be able to check for overfitting and underfitting of these variables. Okay, so by prediction, we're able to see that when we trained, what we got as the outcome was this: 7,000, 28,000, 14,000, 4,000. So there's a variability of the prediction as with the four variable of interest that was used. Okay, when we are training. So let's see by using our text predicted variable. I mean, using our text data. Okay, so when applying our test data on the trained variables, you can see there's a closeness of response. I mean, there's a closeness of results as compared to the price from the initial data sets. Okay, so you can see from this column, 13,000 and 16,000, and so on and so forth in terms of price and all of that. So on the model 5, we see that we have 11,000, which is not so far off, and we have another 11,000 here. We have 15,000 here. Okay, so um, from the look of things, we see that and horsepower and all these other three attributes uh, giving similar. I've given close range. They are giving close range prediction. Okay, giving close range prediction. So with our distribution plot function that we did initially, what we're trying to do here is to also ascertain how the data is being distributed across board. All right. So by this, we see that the distribution plot showcases that the predicted variable and the actual variable are not so far apart from each other. All right. If you remember, by module 4, after we did our prediction, we got our linear function. Our linear function is the, let me reference to module 4 for our understanding. Our linear function is the equation of a straight line. Okay, so this is for multiple linear regression. This is our linear function. Just to confirm, can you hear me? So I'm not talking to myself. Hello? Can anyone hear me? Okay, all right. So I just needed to confirm that I'm not talking to myself. So that's good. All right, so here we are seeing that the distribution plot showcases that multiple linear regression showcase sees tells us that our predicted variables corresponding to our actual variable is closely aligned. So there is no, that shows like the level of accuracy with our prediction, how it can go. Okay, so that is what this plot showcases. So you can see that it's following the similar shape of a predicted variable. So the red color is the predicted variable, while the blue color is the actual variable as we are contexting it. Okay, so more so, what we're trying to do at the end of it all is to ensure that the chosen model in module 4 is serving the best purpose for our prediction. So now we want to check for the test data against the distribution of the test data. So by that, there is an irregularity of plots. As you can see, the predicted variables and the test variables are not aligning properly. Okay, they're not aligning properly. So it means that the test variable is not giving the actual value. I mean, it's not giving us the a much better fitting on our data set. Okay, so in that, what we can get to pick out from it is that comparing it, it is evident that the distribution of the test data, as you can see, is much better fitting than is much better fitting the data. So this difference is that it's apparent that the range of 5,000 to range of 5,000 here to about 15,000 here. Okay, so when you check this end based on our based on the visuals we have, then this is where the shape of the distribution is showing the difference by this cuts in terms of in terms of aligning it with our predictor variable as well as the actual variable. So it doesn't showcase a good um doesn't let us see a good accuracy of our prediction. So our test data to that not is not encouraging as to what we used. So our training data is um, at least a better off than our test data. So what we're going to go on with now is to see how we can best check for overfitting and underfitting. Remember, I said something about overfitting. Overfitting is when the training data is more than required, while underfitting is where the training data is less than required. Okay, just to put it in a layman's term for your understanding. So we're checking for overfitting. Overfitting occurs when the model fits the noise but not underlining the process. Okay, so therefore, when testing your model using the test set, the model does not perform well since it's modeling noise, not the underlying process that generated the relationship. So, but however, in terms of what I just said, by understanding what overfitting and underfitting is. Then, looking at it here, the S train and the Y S test, Y train and the Y test, we are able to see that the test data is given by 45%. We want to see how that's going to go, and by polynomial feature, we are able to align with that. Okay, polynomial feature is not defined, so we need to define and import our library from scikit-learn so that that will be defined for us. So it's not defined. So what we're checking is to see the overfitting of our model. Okay, then we'll go through the options that we have here. Okay, this polynomial transform, I'm still having errors here. The polynomial transform is not defined. Let's see why it's not defined. Where is this coming from? Okay, it's coming from, let's see, from our distribution, from our function definition. That should come from our function definition. Polynomial transform here, polynomial transform. Okay, it's saying that it's not defined. And why is it not defined? Okay, so all right, so here, okay, it's not defined. Everything is in place here. Lots missing one required positional argument, polynomial transform. Okay, so let me access this again. We have S train, S text, Y train, Y test. That is about four arguments. And linear regression and polynomial transform. That is about six arguments. Let's see the number of arguments we have as to why it's not defined on our polyplots. Okay, so from our function, we have S train, S test, S Y train, Y test, linear regression and polynomial transform. Okay, there are six arguments here. Okay. Okay. Seems polynomial transform. This should be able to do it. Polynomial transform dot fit transform. As to the plots, regression prediction. It's supposed to come in here. Okay, so let's just go ahead. Let me see. What I'll do next is to let me. What I'll do next is to debug this error and get across to us on its resolve. So what I can see from the polyplot is showing us that it's not defined, but it's like a name error. But however, the name that we have there is as what you have here. So I'm wondering why it's showing us this error because it's not looking like there's anything wrong in the function. Okay, everything is as it is. Poly transform, so it's defined. Okay, let me change the naming transform and then apply same here and apply same and I run this function again. Let me come down to where I was. I apply same here. Name. Okay, see, still getting the same error. Name error. Okay, so I'll look out for this and get back to you on it. Right now, I can't pinpoint where the error is coming out from. Um, so the other thing is that we can proceed further. The only thing is this: what we are trying to do here is to get the poly plot, that is the polynomial plot. Already, we've gotten the distribution plots as with the distribution function earlier defined. Okay, so and we notice that the test data is not showing. It's not showing what we need to see. And that is not giving us the right reports. All right. So the polynomial function part, the poly plot, is also going to reveal similar response and similar outcome as to what we need to get. Then for the polynomial score, we see that this 55% coefficient of determination with that. Or in other words, we are going to get to say that the polynomial score for the S train data seems always better off than the test data. As you can see here is minus 29. All right, so it's not giving us a good prediction, and then we need to check out for why this is giving us that. All right, so here also we have this view, these visuals on the R squared using the test data, and then the decline from the maximum R squared obtained, which is at 75% based on the R squared. The text data is actually letting us know that the the demarcation in terms of what was used as to 40% or 45% is not good enough to that shows that we have much to do in terms of getting our data outlined in term while we are predicting, while we should also put in mind that we should be aware of overfitting our data and underfitting it. In other words, let's get to know what we need to do subsequently so that we can be able to get our desired outcome. Then for question 4, give us the question to check for polynomial features and obtain for degree 2. Okay, so polynomial is a nonlinear regression is a nonlinear regression method which has to do with curving linear relationship of your data. All right, so what we work on here is to get our data set transformed so that at the end of the day we're able to get the outcome of our data set. Okay, so we applying the trained data set on the same multiple linear regression models. I mean multiple linear regression column. Remember we had a, f- a f- four column that was used for our multiple linear regression in module 4. So that was what was given out there. So all of these questions are just to test our knowledge so that we can be able to understand what we are doing so far. So the replication of what we have learned in terms of fitting our model and applying our trained data sets and the prediction of our tests data to where we are headed and the distribution of our actual values corresponding to our predicted variables. So in all, we are only giving the approach to determine the accuracy of our model by testing out some of this. Okay, so the ridge regression aspect is to test the parameter alpha, and the parameter alpha is used for validation. Okay, so you know that the authenticity of your result needs to be validated, so that one is not one is not one is not giving just whatever it is that you may want to throw out there. It needs to be validated so that we are sure that we're giving the right response. Okay. So here we have the fit transform. The fit transform is also checking in for the multiple linear regression variables that were used. Okay. So we already have gotten that hindsight that from module 4, our multiple linear regression serves as the best model to use in terms of our prediction. Then ridge regression is testing out the alpha, which is for the validity of our model. So when we run through this, okay, so this is not yet defined. The definition, it's get it out there. Then the prediction is 6,570, while the test set is 6,270. Okay, so which is not so far fetched for linear regression. Then for running the TQDM reports, what we are doing also here is to iterate our response to check for the test score between zero point 0.5 and the train set is zero point 0.8. Okay, which we can plot our R square distribution subsequently. All right, so here we're giving the demarcation of our validation data and our training data. The red line is the training data and the validation data is the blue line. All right, so from what you can see on this screen, the blue line represents the R squared of the validation data, as like I've explained. And what we get as the outcome is that the alpha increases. As the alpha increases, the R squared decreases. Then for the the validation data, which is the blue line, also follows a bit of that with the training data. Okay, as it was increasing, you can see how the strike through. I mean, the line moves ahead and got slanty. I mean, got horizontal in the process while it was increasing. But for the training data set, it only increased a little bit before it followed a flat direction. Okay. Then the question 5 gives us we trying to also fit our ridge model and then getting the outcome as the validation score, which is the R squared. Okay, so we're also using the R squared and the mean squared error. So those are the those are our criterion of selecting the best model that was used in module 4. Okay, so what we're only doing in number 5, module 5 is to evaluate our model. All right, so don't get yourself worked up. I know this may seem too cumbersome and also look so um, content filled. What I would advise us to do is to check out the functionalities of the terms that was used in terms of the different sections. Grid search is for hyperparameter, okay, for hyperparameter tuning, and by that, it's helping you to um, to go through the parameters that was used in your data sets, how the futures generation of your data sets, why it was generated, and fine tuning in the parameters to get the best outfit at the end of the day. Okay, so you can see that the best RR score from the test models, which was the multiple linear regression, remembering that horsepower, curb weight, engine size, and highway mass per gallon, which serves as the good predictor of price. They are the variable of interest that was used. And by that, at the end of the day, what we got was 0.84, 1, and so on and so forth. This is an R score, which is a very which is highly accommodated. 80% is a pass mark, is an excellent result as to check the accuracy of our results and accuracy of our model. Okay, 80% is actually a very good score to go by in terms of our grid search. Okay, so what we did in module 5 is to run evaluation to validate our results in module 4. Okay, it's an extension, like I said. I know it's cumbersome, but what I would advise you to do is check the line item to understand the functionality of what grid search did. Like I said, it helps in hyperparameter tuning. By tuning, it helps to run loops. Okay, it runs the loops of your parameters to let you know the best R score. Okay, then while for the ridge regression helps to run iterations. Ridge regression, in other words, can be regarded as stepwise regression. Okay, it's running regression in steps accordingly. You may not see the dynamics of how it works on here, but by description, that is what it does. Okay, so I'm summarizing the Module 5 for us so we can just get to understand what Module 5 is all about. All right, so you may not be required to um, you may not be required to say, okay, you have to do exactly everything that is on here. So, but just for you to get the context of what Module 5 is, then you be able to draw insights. You draw, you have it like a reference point where you can move ahead. If you want to validate your results, you can go through with Module 5 to do that. Okay, so with this, we've come to the close of this lab for Module 5. Okay, the floor is open for any deliberations from you. You can unmute your mic and go ahead to speak. We are far behind time. We'll soon be rounding up. Okay, so can I get any deliberation from you? How do you, how is your understanding like? What is it that you have as your question? Yes, I can hear you. Good afternoon. Okay, okay, okay. Fitting your fitting your data. Where are you? Is it on module 3 or module 4? Okay, module 4. Um, so for module 4, when you want to fit your data, you please mute your mic. I can hear myself. Okay, I think it's better off now. Um, by fitting, you have the different models in module 4 when you want to fit. Okay, um, there's fitting for simple linear regression, there's fitting for multiple linear regression, and there's fitting for polynomial regression. Okay, so where you need to get your where you need to pick up your learning is on the function. What are you fitting? First of all, you need to get your variables out. Are you fitting a particular variable to the target variable being price? Let's take for instance on my data set, I want to fit horsepower on price. Okay, I want to fit in the model. So by fitting in the model, what approach am I going to use? If I'm only going to fit in horsepower on price, it therefore means it's simple linear regression. I'm going to apply. Okay, I'm going to apply my simple linear regression in fitting that. So, but coming down to simple linear regression, we have our linear function as this. The linear function is an equation of a straight line. Equation of a straight line gives you the the equation for your prediction, where you can get the outcome of your prediction by substituting in the response variable, which is x. Okay, already you'll be given already you get your intercept and slope out of it. Now, by the function, We are going to import the library. We're going to import the library which is from scikit-learn, importing linear regression, and following through with that, we also ensure to align a variable to our linear regression, which is lm. Okay, so in that we've we've activated our linear regression model. So we're going ahead now to fit our highway mass per gallon on price. Okay, so by that we're applying the fit function since we already have given uh, since we've identified our linear regression as lm. Lm is a variable. Okay, is a variable that is holding the linear regression object, having imported it from our scikit-learn library. Okay, then when we've done that, we'll come to define our variables. Our variables, which is the x independent variable, is in this case we're using highway mass per gallon. And our target variable, which we already know, is price. Okay, so we are going to now fit highway mass per gallon on price to see how the outcome is. Okay, so by that, what we are trying to do is to, after we fit in highway mass per gallon, we apply our prediction to it, which is the linear function here. This is for our prediction after we've done our fitting. Okay, first of all, you import your library. After import your library, you define your linear regression object, and then define our variables, and then you fit using the fit function as given here. Okay, whatever variable it is that you use, you can use it to do the same thing. All you need to understand is the fit function will have to have two arguments. The two arguments is the dependent variable and the independent variable if it's for the simple linear regression. But if it's for multiple linear regression, it's going to have the the dependent variable and the independent variable. The price is the independent variable. Okay, so then you have response variables of more than two for the sake of multiple linear regression. You have response variable that are more than two. So first of all, you have to define you have to define a variable that will hold those multiple linear regression variables. Okay, like this. Take for instance, we are defining z and we are holding the horsepower, just exactly what we've done before. Okay, we're holding the horsepower, wheelbase, and things like that. So what we're just trying to do is to ensure that we have our multiple linear regression. So, but however, it can as well be done the same way. It can as well be done the same way of highlighting the different column that you want to use, and then we have engine size and um, fuel type. So I'm just calling out columns, okay? So just to highlight how you can be able to fit your models. You can be able to fit your models. So here, this is for multiple linear regression. So Z is serving as the variable to hold four columns, okay? Four columns against price. So if you are to fit this based on multiple linear regression, you can call your variable L ML R, okay, is equal to MLR dot fit Z by Y. Okay, so Z is holding the four columns. Okay, you're fitting it against price, which is this as identified here. I don't know if that's clarifying for you. Okay, you're getting an error. Okay, so what you can do for me is to share the screenshots of that error and send. So that's fine. How just get the screenshot out and send out on the general channel so that every other person sees it. So while I'm responding to it, every other person sees it as well. You're welcome. Okay, so um Verve to communicate subsequently to you guys on the next step, which is the final exam and project exhibition and exposition. I've just done the project exposition to you guys. I will share the resources to you, then I also support you with some of the relevant links that you can download data set from and practicalize what you've learned so far. Okay, so always reach out if there's anything you do not understand and you don't have clarity on. We'll be able to assist you. Okay, what is that? Okay, so if you're downloading from Cargo, yes, with your mic, it seems like you have two Google Meet opened, and as I'm speaking, it's reflecting on your own side. For Cargo, when you are downloading, even if it comes in as zip, you can you can extract the file. Okay, so because the tendency is that the other dependencies within the dataset that you want to download will also come in terms of some temporal files that is supporting the documents that you want to download. Let me just practicalize one here. Say for instance, I'm accessing this dataset. Um, okay, so here he has about 41 datasets. Data science consultant and freelancer, Princeton, New Jersey, United States. So let me check his data set that are available. We have Parkinson files, and then on here we have the download button, okay, which is 2 megabytes. When I click on it, it's okay. I have to sign in. I have to sign in for me to be able to download. So when it comes in zip file, there is no cause for alarm. All you need to do is unzip it, extract the data in it. If there's any other data you do not need within that file, you also delete because originally those data sets may have other supporting files within the folder. So that's why it comes in zip file. Okay, some other may come only on the data set, the CSV itself. So when it comes in zip file, there's no cause for alarm. You can always extract it. You can't you can't you can't control what you're downloading. You are downloading from a source which have already uploaded it by themselves. So while they're uploading it, they uploaded it in zip file. So if you are downloading from them, you are going to download as they uploaded it. Okay, so it's now left for you to extract the data and make do of the file that you want to make use of within it. So now I think I'm signed in. If I click on downloads, it downloads it still on zip file. You can see. So all you need to do is just to extract it, show it in format, and open it. So if it's in GitHub, you can download directly from CSV. You can download it still on zip file. So there's no cost for alarm. It's how it's what uploaded that you can download it on. I don't know if you understand. So look at what I'm doing now. So I've just downloaded it, right? So this is it, archive.zip. I right click. When you right click, you see from the context menu, extract all. Okay. So you click on extract, extract all. When you click on extract, save it in the same folder that the file was downloaded into. Then you come down to extract, and when you click on it, it will extract the file and open it up here. You see, it's what I said about having supporting files within the folder, and that is why it's zipped. Okay, so you can see from here, after extracting the file, I discovered that there are two files within the data sets. Okay, one is in CSV, the other one is in Excel. Okay, as with the extension, as you can see here. I don't know if you understand now. So you're welcome. So yes, that's how to go about it. Okay, so at this point, if there are no further question or comment from any of you, we'll be closing out on today's section, and then I will be supporting you guys and sharing subsequent materials and resources to round off well with your program. Okay, so don't worry, I have I have some of the things I want to do for you guys that will be beneficial and be helpful as you progress with your career in data analysis. Okay, just stay put and keep on working. Thank you all for listening. At this point, we've come to the end of today's live section. You're welcome. Okay, so until when next we see in terms of a project exposition. All right, have a wonderful Easter ahead and enjoy the rest of your day. Bye for now.